Hello everyone, welcome back to another video. In this video, we'll be solving the question coin change combinations. Now this question is just a slight variation of target sum subsets, right? So let's look at the problem statement and see what it says, right? So if we take this whole part and read it out, it says that you are given n numbers representing the count of coins and you are given n numbers representing the denomination of n coins, right? So you would be given n number of coins, right? You're given a number amount. Along with that, you would be given a number amount, right? So if you read the fourth point, which is the most important point more carefully, it says that you are required to calculate and print the number of combinations of the n coins using which the amount AMT can be paid, right? So out of all of those coins, you have to pick the coins, make a subset, right? Make a combination such that the summation of that subset is equivalent to amount, right? So that we can pay that amount. Okay. Now, if we look at the notes, it says that you are having an infinite supply of each of the coins, right? That is, same coin can be utilized many number of times, right? Over here, we can see that it all says that you're required to find the count of combinations and not permutations. That is, 2 to 3 would be different from 2, 3, 2 and 3 to 2, right? So we only have to take one output out of these three, right? So I hope you understood the question, right? Let's take an example. Let's take an example to understand this a bit better. So if we go to the website, if we go to portal, and if we look at the sample input and output, if we take this, right? So let's analyze what it's saying, right? So the first number is the representing the number of coins. Then we have these coins, and this is my amount. So if I write this, we have 2, 3, 5 and 6. These are my coins, and what I have as amount is 7, right? So out of all of these coins, I have to pick coins. I have to pick coins with repetition such that its summation is equivalent to amount, right? Now, if you recall target sum subsets, in that particular question, what we did was we had an array of elements, and we had a target, right? We had to pick elements such that the summation of that subset would be equivalent to the target, right? We have to fulfill a target. But the only catch was in that question, in target sum subsets, repetition wasn't allowed. That means if we are picking a particular element, we can only pick it once, right? But in this question, repetition is allowed. So the only difference is of repetition, right? That means I can utilize my 2 multiple number of times. So to make amount of 7, what I can do is I can have 2, 2 and 3, right? So this is one combination that satisfies the sum of 7, right? Another combination would be 2 and 5, right? So for these coins, these are the two combinations that have a summation equivalent to 7. So my output would be 2, right? In output, I just have to give the count of those combinations, right? I hope you understood the question, and I hope you understood the relation between this question and target sum subsets, right? So I would want you to go and try this question out on your own. If you get stuck somewhere, take help of either the article or this video, right? So moving on to the solution, right? So we would be solving this question using DP, and as we already know, we have 3 basic steps in DP. The very first thing is to assign storage and meaning, so we would be focusing on that. Second is about the direction, and the third one and the last step is traversing and solving, right? So for the very first step, which is solving a storage and the meaning, what I would do is I would create a 1D array of size amount plus 1, right? So let me just create that array. So if I have this, I was like this, right? And this, okay. Now 0, 1, 2, 3, 4, 5, 6, 7, and 8 over here, right? So I have a 1D array of size amount plus 1. So my storage is 1D array of integer type of size amount plus 1. Okay. Now what about the meaning, right? What about the meaning, right? So let's make proper separations and derive a meaning for all of these, right? So draw this, 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 and then this. What I'm interested in knowing is what would this mean, right? What would, if this is my DP, this is my storage, then what would DP of 2 mean, right? DP of 2 means what are the number of ways, what are the number of combinations using the coins that I have such that I can create a summation of 2, right? Such that my amount is 2, right? What are the number of combinations that satisfy a total summation of 2, right? So if my amount was equivalent to 2, what are the number of combinations that have a sum equal to 2, right? Now, similarly, if we talk about DP of this, right, DP of 8. Okay, this is DP. We would only take till DP of 7, okay, in this case, because our amount is 7. And if we have taken an array of amount plus 1 size, then the indexes would vary from 0 to 7. So if we talk about this place, DP of 7, right? For this particular input, we are doing this, right? So my amount is equal to 7, right? So DP of 7, according to the standard definition that we saw, it would be what? It would be the number of combinations such that I can have a sum of 7, right? DP of 7 is nothing but DP of my actual amount, right? So if we reiterate over the definition that I just said, in DP of amount, we would have the number of combinations that satisfy the sum of amount, right? Using all the coins that I have, right? So this is my answer itself. So DP of amount would contain answer of my question, right? This particular point would contain answer of my question. Makes sense, right? If we go back and if we think about DP of 0 now, right? DP of 0, what would DP of 0 mean, right? DP of 0 says number of ways in which I can make 0, number of combinations such that my sum would be equivalent to 0. Now to make a sum of 0, do I need to take any coin at all, right? I don't have to take any coin. To pay zero amount, I don't have to give anything. That's the only way of paying 0, right? So DP of 0 would be 1, right? And that is an empty subset, right? An empty combination, right? We don't do anything, right? So this would be our base case, right? So we have done our very first step, which is assigning storage and defining meaning of that storage, right? Now the second part, which is direction, it's quite clear and evident that if we have our base case at 0th position and if we have our answer at the last position, then we have to move in forward direction, right? So we would be moving in forward direction. So we know the direction part also. Now, what we are interested in is the third point, which is traversing and solving. So to traverse and solve, what I would do is I would write the coins that I have. The coins that I have are 2, 3, 5, and 6, right? So if I come over here, I can focus on just this part. I can have 2, 3, 5, and 6 written like this, right? So these are my coins, right? Okay. Now what I would do is I would start traversing from first index, right? And I would start traversing from first index till last index using my 2. So what I would be doing is I would be using 2 to make sum of all of these, right? Let's see how we can do that. Now if I come over here, I would have to check if the sum that I want to do is smaller than the coin value itself, right? Can I make a sum of 1 using 2? No, right? Sum of 1 can only be made from a coin that has either value of 1 or smaller than 1, right? And as we are dealing with integer values, then only a coin of 1 value can make a summation of 1. And currently we don't have that coin. We are interested in knowing whether I can have 2 or not, right? So in this case, what would happen is my 1 would be 0, as there are no ways to pay 1 using 2, right? Now what I would do is I would move to next index, which is 2. Is there a way in which I can pay 2 using 2 coin? There is one way in which I can pay that. That is if I use 2, right? So if we think about it, what we did was we took 2 and we asked a particular coin, can I make a total summation of u, right? I asked summation of 2 if I can make it using my 2, right? So if you think about it, this question is nothing but of the type of source and destination. So we have source equivalent to our summation that we want, right, which is index, right? And from that source, what we have to reach is 0, right? Because we have to reduce our amount till 0. We have to pay our amount till 0, right? So my 2 comes and my 2 says, okay, can I pay from 2 to 0, right? So 2 says, okay, if you have 2 over here, then I can pay 2 and get to this point. This point is 0. That means there is one possibility, right? And that possibility is not doing anything. So I would add 2 in front of that, right? So I would give just 2 over here and I would pay my entire amount, right? Let's move on to third one, and let's move on to third one. Let's iterate it for a few times and then it will be much more clear to you, right? So 2 goes to 3 and asks 3, can I pay you, right? So 3 says, okay, if you pay 2, you would have a remaining amount of 1, right? So if you pay 2 from 3, you would have a remaining amount of 1. So then it would go to 1 and ask how many ways are there in which I can pay you, right? How many ways are there in which I can pay 1, right? And 1 says there are currently no ways. So that means 2 also doesn't have any way of paying 3, right? Now 2 goes to 4, right? 2 goes to 4 and says how many ways can I pay you? So 4 says, okay, if you use yourself, that is 4 minus 2, you would have to pay additional sum of 2. Now 4 goes to 2, dp of 2, which contains total number of combinations in which it can pay 2, right? So 2 says there are only 1 ways. What is that way? If you use your coin 2, right? So 4 says you can only pay 0 from me if you attach 2 at the end of all the combinations that are at 2. That is 0.22, right? So there is 1 way, right? If we erase this again, 2 moves forward to 5, right? And then it asks 5 again, the same question, can I pay 0? Can I pay 5, right? So 5 says if you pay yourself, if you use yourself, you would have to pay a remaining amount of 3. So it asks 3 if there is any way to pay 3. 3 says no, there is currently no way in which you can pay 3. So 5 says sadly, if you use yourself here, you won't be able to pay, right? So we have 0 combinations in which we can pay 5, right? Then 2 goes to 6, right? 2 goes to 6 and asks the same question. 6 says, okay, if you pay yourself, you would have to go to what? 6 minus 2, which is 4, right? It asks 4 if there are any ways to pay 0 using all the combinations that already exist. 4 says there is one combination, which is 0.22. So 6 says if you want to pay 0, if you want to pay 6 using 2, you have to attach 2 at the end of all the combinations. That's 4. So this is 222, right? Now, again, my 2 goes to 7 and it asks 7 if I can pay you. 7 says, okay, let me see. 7 minus 2, which is 5. It asks 5. How many ways are there in which you could be paid? 5 says 0. So 7 says, okay, if you use 2 currently, you don't have any way to pay 7, right? So 0 over here. What we have done is we have iterated over the amount over here using our first coin. Now what we would do is move on to next coin, right? So my pointer over here would move to next coin, right? This coin. Now we are at 3, right? So 3 would then iterate from 1. It would say, okay, can I pay 1? As 3 is greater than 1, it can't do anything, right? So 3 would simply ignore 1 as well as 2, as 2 is also smaller than 3. There is no way in which 3 can be utilized to pay 2, right? 3 would start from 3. All right. 3 would ask 3 if I can pay you, right? So 3 says, okay, let me see. So it does what? It does 3 minus 3 and it goes to 0 to ask how many ways are there to pay 0. 0 says there is no way to pay, there is only one way to pay 0, which is not doing anything, right? So 3 says, okay, there is one way in which you can pay 3 using 3, which is just add me and do nothing, right? Okay. Then my 3 goes to 4, right? 3 goes to 4 and asks if there is any way in which I can pay 4 using 3, right? So 4 says, let me check. it goes to 1, which is 4 minus 1, 4 minus 3, right? 4 minus 3 is 1. It asks 1, how many ways are there in which I can pay 1? 1 says there are 0 ways. So 4 says to 3 that if you use yourself, you would have an amount of 1 remaining to pay. And sadly, there are currently no ways in which you can pay 1. That means you cannot pay 4 if you use 3. Right? Now, as it would remain 0, there won't be any changes, right? So now 3 goes to 5, right? 5 minus 3 gets to 2. So 2 says there is only one way. If you attach your 3 at the end of all of my combinations, which is just a single combination using 2, right? So what 5 says is if you attach yourself behind 2, you can pay 5, right? So total number of combinations increase to 1 over here. If we move forward, 3 goes to 6, 6 minus 3, right? 6 minus 3 gets to 3. 3 says there is only one way, which is 0.3. So 6 says, okay, there is one way, there is one another way if you use 3 and 3, right? So a total of 2 is over here, right? Again, what happens? 3 goes to 7. 3 goes to 7. 7 minus 3 gets it to 4. 4 says one way using 0.22 and attaching 3 at the end of it, right? And then 7 gets updated with one way, right? So after iteration using 3, we have one single way of making 7, right? That means using these two coins, 2 and 3, I can make a combination, I can make a single combination that has a summation equivalent to 7, right? Right? Now, what would happen is, I would switch my coin again, I would move to 5, right? 5 would start evaluating itself from 5 as all of the rest are smaller than 5. So 5 would say, okay, if I use myself, I would get to 0, right? 0 says there is no way, so you can just use yourself. So this increases my count over here to 2, right? Again, 5 moves forward to 6. 6 minus 5 lands it to 1. 1 says there is no way, right? So if there is no way, count won't increase, right? Now 5 goes to 7. 7 minus 5 gets it to 2, right? 7 minus 5 gets it to 2. 2 says there is one way if you use yourself after me, right? So this increases to 2. All right. I hope you understand what we are doing now. I hope it's much clearer now. So after iteration with 5, using all of these coins, that is 2, 3, and 5, we can make two combinations such that the summation of those combinations is equivalent to 7. Right? Now moving forward very quickly, what we can do is we can move to the next coin, which is 6. Right? 6 would start its evaluation from here because 0 to 5 cannot ever be paid using 6, right? So 6 would say, okay, how many ways are there to pay myself, right? So 6 would go to 0. 0 would say just one way, do nothing. So 0.6 over here would increase its count to 3, right? Then what would happen? What would happen is 6 would move forward to 7th index, right? Then it would ask 7, how many ways are there in which I can pay 7 using myself. So 7 goes back to 1, right? To ask how many ways are there in which 1 can be paid. 1 says there are no ways in which I can be paid, right? Okay, there are no ways in which 1 can be paid because all of our coins are greater than 1. So 7 gets 0. That means 6 cannot be used to make 7 at all, right? So after iteration, what we are getting is after using all of these coins, the total number of combinations such that we can generate 7 are 2, and these are those two combinations. So if we look forward, if we look up over here, and if we see, these are the exact combinations, right? So I hope you understood what's happening, right? I hope you understood. Let's try to code this, right? So what we have is, the very first thing is what we have is a number n, then n numbers which represent coins, and then our amount, right? So let's take that input, which is new scanner system.n, and then n is equal to sc dot next int, and then I have to take input for coins array. So that would be of size n. For int I equal to 0, I goes till n I plus plus, and coins of I is equal to sc dot next int, right? Then I have to take another input, which is my amount. Now, from over here, we would be writing our solution. The very first step in our solution is to assign storage, right? So what was our storage? Our storage was a 1D integer type array of size amount plus 1, right? So integer type array of size amount plus 1, right? Then what was our base case, right? Our base case, if you remember, our base case was that when we are at position 0, there is only one way to pay 0, that is we don't do anything. So dp of 0 would always remain equivalent to 1, right? This is our base case. So dp of 0 is 1, right? Now what we have to do is traverse and solve, right? Let's see how we can do that. Okay, so the very first thing, we have to pick a coin, and using that coin we have to iterate over amount. So we would have a loop running on coins, right? So I equals to 0, I goes n I plus plus, and using that particular coin, so we would have a coin over here which is coins of I, right? And using that coin we would have to iterate over the amount array, right? Now we can start using the coin, right? That is because to evaluate an amount, the amount should be greater than or equal to coin. So we can start with coin itself, right? Because we cannot make a summation of 1 using a coin which is valued at 6, right? We have already discussed this. So we go till how much? Our amount, right? And j plus plus over here. So j is nothing but my current amount and coin is my current coin, right? Now what I have to do is I have to ask my previous state, right? So my previous state would be my current amount minus the coin, right? This would get me total number of combinations in which I can make amount of I using coin over here, right? This coin. Okay, I have to add this to dp of I, right? So what I'm doing is if I have a dp of I, let's suppose what I did was, if I'm over here and this is already 1, and if this is 1, I would call back to this point, I would get one combination from over here and I would update this to 2. So what I'm doing is 1 plus 1, right? So we are adding new number of combinations to the old number of combinations. So that's why it's plus equal to, right? I hope you understood, right? Okay. What's next? After this iteration, we would get our answer in dp of amount, right? So if we print that, this should get our answer, right? So let's try to run this to see if there are any compilation errors or not. So we get a runtime error that is on over here, which is saying that we have a -2 error, right? So that is because if we take a coin and if we are moving forward in the coin, what we have to do is we have to update jth position, right? We have to update current sum. We have to update current amount, right? Which is j. So instead of I, we have to update j, right? If we run this again, it's accepting the test case. Let's submit it for all the test cases and see. It's taking a bit of time. Okay, so it submits. We are getting a correct answer, 10 out of 10, right? So if you look back, so the error that we were getting was because of swapping of the digits j, swapping of the variable j with I, right? So that was the error, right? Okay. Now, if you look back again, what we did was assign storage, define base case, and then traverse and solve, right? Basic DP question, right? I hope you understand how we are generating the combinations, right? We are generating a combinations. We are generating the combinations by using a single coin at a time and traversing over all the amounts, right? So if I'm using 5, I'm using 5 after 2 and 3. That means my 5 won't ever be followed by 2. That means if there's a 2 5 over here, I won't get 5 2 ever again. If I have 2 2 3 over here, I won't get 2 3 2, as 2 cannot come after 3 and 2 cannot also come after 5, right? So this is how we are preventing arrangements from happening, right? This is how we are preventing permutations from happening. Now this question was about coin change combinations. The very next question that we would see would be about coin change permutations. In that particular question, we would be interested in generating these permutations, right? So there is just a slight difference. There's just a single slight difference in the entire code, using which we can just easily generate all the arrangements as well. So please watch that video as well. It is just the next video in this series. Now, if we come back over here on the code, and if we talk about the time complexity, right? So the time complexity for the following, for the code over here, it's simply O n square, right? We are using 2 for loops, and the space complexity is of O n, right? To be exact, it's of O amount plus 1, but to make it more generalized, we can say O n, right? We are using an integer DP array, right? So I hope you understood the question, and I will see you in the next question. If you like the video, please share it with your friends. So see you. Bye bye.